In this presentation, we will see the behavior of master-slave D flip-flop, and for this I will draw few waveforms, the output waveforms here, and once I am done with the waveforms, I will draw few important results. Like what is a glitch, how to remove a glitch, what is the relation between the master slave flip-flop and the negative edge triggered flip-flop. For that we have to find out QM. QM is the output waveform of your master flip-flop. Similarly we will find QS, the output of the slave flip-flop, QP, the output of the positive edge triggered D flip-flop, and finally Qn, that is the output of the negative edge triggered D flip-flop. We have to find all these four waveforms by using the truth table of the D flip-flop. But before actually going into this, let me first explain you the signal I have already drawn. I am having my clock, the green one is my clock, and the D signal is the input to the D flip-flop, and you can see I have taken a random signal. It is not that much random because it actually covers all the possibilities. Now what are the possibilities? The first possibility I can talk about is when the clock is low but the signal is high. Here you can see. Similarly, if I talk about the second possibility, then the clock is high and also the D signal is high. In the same way, it covers all the rest possibilities. That's why I have taken this signal for the analysis purpose. So let's go into this. And we will start first by discussing this master slave operation, what it is. You have already learned about these things in a separate presentation, so when we were having the discussion on the JK flip-flop. So master slave flip-flop consists of two flip-flops. The first flip-flop is called as the master flip-flop and the second flip-flop is called as the slave flip-flop. The most important thing to remember about a master slave flip-flop is the clock. The clock is given to the master, but the same clock is inverted by using a NOT gate and then given to the slave. The greatest advantage of this configuration is the toggling. We have toggling instead of race around condition in the JK flip-flop because we eliminated the effect of feedback there. The feedback was eliminated because when the master is operational, slave is not, because we have inverted the clock. Similarly, when the slave is operational, master is not, and this is all you have to remember about a master slave flip-flop. We will not go in much depth because we have already covered these things. So I will use the truth table for a D flip-flop, and if you don't remember, there is no problem. I will make one clock D and the output is Qn plus 1. When the clock is low, whatever be the value of D, Qn plus 1 is going to be Qn, that is the memory state, and when clock is high, D is low, Qn plus 1 is also low, and when the clock is high, D is 1. It means D is also high, output is also going to be high. This is because when D is 0, it means S is 0 and R is 1, and when D is 1, it means S is 1 and R is 0. So we will use this table to find out the value of QM. Now let's see what is the thing on which the QM is dependent. The first thing is the D signal that I have drawn here, and the second thing is the clock. And this master flip-flop will be operational when the clock is high. So we have to check only for the pulses when the clock is high, or you can say the time interval when the clock is high. So let's start plotting our QM. QM is a 0 for this high pulse because D is 0. You can see from here, if D is 0, the output is 0. So I have QM 0 up to this point, and again when the clock is high, you can see D is high, so QM will also go high till the next high pulse. And in this high pulse there is something very interesting going on which will cause the glitches. You can see D, our input signal, is low for a small time and again it becomes high when the clock is high. So we are changing the input D signal in the high pulse. So what I have as QM is, it will be low initially and again it will become high till the next high pulse, and when the clock is high again, the D is high, so it will remain high for the next high pulse, and for this high pulse you can see D is low, so it will again go low, and finally here again we can see the input signal is changed during the clock. it is high initially, then it goes low. So our QM will also follow this. It will remain high initially and then it will go low. So this is the QM, and now we will move to QS, that is the output of the slave flip-flop. And you have to remember one important thing for the QS is the clock is inverted. We have to see for the time when the clock pulse is low. It means we have to see for this time and this time period. We have to see only for the time when the clock is low. It's very obvious because of this NOT gate. And also we don't have to see a D signal. Okay, we have to see QM because QM is acting as the input for the slave flip-flop. The D isn't, the QM. So we have to see QM and the clock when it is low. So let's try to get our QS. Initially QS will be low because QM is low, and it will remain low till the next low pulse when the clock is low. And here you can see when clock is low, QM is high. So our QS will also become high till the next low pulse. And again for this low pulse, the QM is high, so it will remain high. And for this time when the clock is low, you can see QM is again high, so it will remain high. And for this low pulse, QM is low, so finally it will go low. And for this low pulse, QM is low and it will remain low throughout. So this is my QS signal. You can see it is very easy to draw once you have the truth table for the D flip-flop. Now we will try to have QP, that is the output of the D flip-flop simply, not the master slave one. It is the output of a simple D flip-flop when the input is given, and the input is this D. We don't have to do anything with the QM, it's only for the slave. So the input is D, and we have to check, or we have to actually consider the change in the circuit when the clock goes from low to high. It means all the rising edges. This is the positive edge triggering, you already know, and we have to consider that the D flip-flop is working only when the clock goes from low to high. So let's check what we got in case of QP. I will change the color. Now you can see QP is low, and for this rising edge again D is low, so it will remain low for the next rising edge. And for this rising edge D is high, so QP will go high till the next rising edge. And for this rising edge D is low, so it will become low and remains low for the next one. And for this rising edge D is high, so it will go high and remains high. And again you can see for this rising edge D is low, so it will go low. You can check from the truth table. When D is low, output is low. When D is high, output is high. So I'm not going to tell you this thing again and again. And for this rising edge you can see D is high, so it will remain high, and finally it will go low. So this is the output waveform for the flip-flop, which is positive as triggered, and the input signal is given here. Now finally the last waveform is for the negative as triggered flip-flop, and it is very important. We have to draw various results from this thing. So let's try to find out the output of the flip-flop when it is negative edge triggered. We will consider all the falling edges, and I will use some different color for this purpose. Let's use white for this, and you will see some very good thing in a minute. I will just see these falling edges, and for this falling edge D is low, so it will remain low for the next falling edge. And for this falling edge, this one D is high, so it will go high. And again for this falling edge D is high, so it will go high till the next falling edge. For this falling edge again D is high, and finally for this falling edge D is low, so it will go low. And for this falling edge D is low and it will remain low. So we are done with our 4 waveforms. Now let's try to find out few important things out of it. The first thing I will tell you is the glitches. You can see these sudden changes in the output signal. We call them glitches, glitches, and they are definitely not desired things. And the very important point that I'm going to make is, you can see for the slave output the glitches are removed. There is no glitches in the slave output. That's why to remove the glitches we use master slave flip-flop. And why the glitches are appearing in the output? Because we are changing the input signal when the clock is high. So it is definitely not desired thing to do. The input signal must not change when the clock is high. This is not a common practice to do, because we will have a glitches in our output. And if you want to remove the glitches, you have to use the master slave flip-flop. This is the first thing that I want to clear here. Now we will move to the second important point, is the relation between the master slave flip-flop and the negative edge triggered flip-flop. You can see the master slave flip-flops output is same as the negative edge triggered flip-flops output. So I can say the master slave flip-flop work as a negative edge triggered flip-flop. So these are the two things that we have drawn from these waveforms, and they are very important. You have also learned how to draw the waveforms for the output of a D flip-flop. So it's already a very good lecture for you. You have learned so many things. If you have any problem regarding any point in this presentation, you can ask in the comment section. I will end this presentation here because I think we are crossing the time. So let's stop it here. See you in the next presentation.